Okay, so in the next one, what did y'all get as your answer? 3. Because it would be -2 times -1.5. So that would yield 3. All right, now, the 0 to 6 of 2 plus f of x, we break that down into 2 separate integrals, so it's 0 to 6 of 2 dx plus 0 to 6 of f of x dx. Now, we know what 0 to 6 of f of x dx is. It's 3.5, yeah. So now we have to do for 2, so the antiderivative of 2 is 2x. So we're going from 0 to 6, so it's going to be 12 plus 3.5, which would be 15.5. That would be the solution. We'll see if I don't know that I got all that on the board. All right. So, is there a question about that? All right, let me take this off of the, well, no, we need to do the average value, right? So what would I do to calculate the average value of 0 to 6? It would be 1 over b minus a times the integral from a to b of f of x dx. So what are a and b in this case? 6 and 0. So it's going to end up being 1/6 of the integral from 0 to 6 of f of x dx, which is 1/6 of 3.5. And again, as far as the AP test is concerned, you wouldn't even have to do that arithmetic. You could just leave it as 1/6 of 3.5. That'd be 7/12 if you wanted to write it as a simplified fraction. Is there a question about that? All right. So, and again, that 7/12 would be probably somewhere right in there, giving us the average value for the function. Again, the majority of that function is above the x-axis. That's the reason why you've got an area that's greater than 0 there. I'm sorry, you've got an average value that's greater than 0. All right, we go a little bit further with this. Let's look at question 76 there. 76, it says, we've got that g of x, and they give us this figure, and I'm going to draw out the figure just for the purposes of it's easier for me to reference it. We go 0 down to 2, -4. And then we come up to 4, 0. And then we go up to 5, 4. And then we go across to 7, 4. Then we go down to 8, 0. All right. So we want to define this function. This is a function of f, and we're defining g as being the antiderivative of 0 to x of f of t dt. Well, the first one wants us to calculate g of 0. So g of 0 means we're going to go from 0 to 0 of f of t dt. So what is that area when I go from 0 to 0 of that function? It's 0. Yeah. Remember, anytime your lower limit of integration and your upper limit of integration are the same, you've got an antiderivative value of 0. All right, the next one is we're going from, it's g of 2. So we're going this time from 0 to 2 of f of t dt. So what are we looking at here? We're looking at wanting this area right there, which of course is a triangle. So it's going to equal to 1/2 of the base times the height. What's the base here? 2. And the height is what? 4. But now, because this region is the region below the x-axis, it's going to be the negative of that value. So we end up with -4 as our solution for g of 2. Is there a question about that? All right, now, y'all do the g of 4, g of 6, and g of 8. We'll do that in just a little bit. We won't get to that now. Part B. What does part B say we're looking for here?
The largest open interval in which g is increasing.
The largest open interval in which g is increasing. All right. Now, g is going to be, it starts off at 0, right? And g decreases from 0 to 2. That should make sense. We start out at 0 at g of 2. We're at -4, so we see that we're decreasing here. Now, the trick here is that f is increasing from here to here. But g is actually decreasing. Because this is still negative right in here. So actually when we get over here to g of 4, we see that our solution for g of 4 is 0 to 4 of f. We get -8. Because it's 4 times 4, half of that. So we get -8 there. So even though f increases from here, g doesn't. Now I want us to look at this a different way. G of x is equal to the antiderivative of f of t. Now, if we want to know if g is increasing, then what do we know about g prime? If g is increasing, what do we know about g prime? It's positive. So g prime of x is equal to f of x. Does that make sense? the derivative of the antiderivative is the function itself. So, if I want to know where g prime is increasing, really what I want to know is where is f of x positive? Well, where is f of x positive? From 4 to 8. That would be the largest open interval in which, it says largest open interval in which g is decreasing. I'm sorry. That'd be the largest interval where f is increasing. The largest interval where g is decreasing is where f of x is negative. So I could say f of x is negative from 0 to 4. So g is decreasing where f is negative. All right, let's look at part C here. It says find the extrema of g. Find the extrema of g. Well, where do we find extrema? Where the derivative of a function is equal to 0, right? So, or at an endpoint. Now, in this case right here, so we want to know the extrema is going to exist where g of x equals, where g prime of x equals to f of x, which equals to 0, and g changes, not g changes signs, and where f changes signs. So, that would be, all right, at 0 I'm going to have an extreme value. At 4 I'm going to have an extreme value, and at 8 I'm going to have an extreme value. Does that make sense? All right, now, what I want y'all to do is to finish out question part, the part A. We actually did g of 0, g of 2, and g of 4. So I just need y'all to do g of 6 and g of 8. All right, do we have an answer for g of 6? All right, where'd you get the 6 from?
Finding the area between 4 and 5 and adding
Alright, so the area between 4 and 5 was what?
2.
2. The area from 5 to 6 was 4. Okay. But now remember, we're starting here at 0. So it's going to be negative 8 plus 6, which is negative 2. So see, G is increasing. It's still negative though, but G is increasing there, and then add 6 more to it. So basically, I'm going to write it like this. F of 0 to 8 is the same thing as 0 to 6 of f of t plus 6 to 8 of f of t. 0 to 6 of f of t, we already solved that out to be negative 2. 8 to 6 of f of t is positive 6. So we get negative 2 plus 6, which is 4. Does that make sense? All right. So the directions here want us to sketch this graph in the last part. Sketch this graph. Well, let's plot some points first. First point I'm going to plot is 0, 0, right? Okay. The next point, I'm going to go to 2, and I've got 2, negative 4. All right. Now, at 4, I'm 4, negative 8, so I've got to actually go down here. I should have thought about that before I did this. All right, now, past that, G of 6 is negative 2. So I'm here at 4, then I jump up here to negative 2 at 6. And then I'm at positive 4 when I'm at 8. All right, now, I know I go from here to here to here, then to here to here. But I mean, how do I go? Do I go in straight lines? Do I curve? What do I do here? Well, if I want to know the shape of it, I have to think about the concavity. Now, concavity would be the second derivative, right? So, G double prime of x is equal to f prime of x. So, to look at the concavity of this graph, I need to see where f is decreasing. Here, f is decreasing, so I will be concave down from here to here. Does that make sense? Okay. So I'm going to sketch something that goes from here to here and is concave down. All right. Now, f starts increasing from here to here. So f is increasing from here to here. So now f turns concave up. I'm sorry, G turns concave up. G is concave up, but we are still decreasing. So the graph does something like that. All right. From 4 to 5, f is still increasing, but G is going to start increasing here. So we're concave up going here. Now, we didn't have to graph. I'm sorry, I needed to stop right here. We didn't have to graph G of 5 or G of 7, but G of 5 and G of 7, we are neither increasing nor decreasing here, right? I mean, F is neither increasing nor decreasing. Now, G is increasing because it's got a positive F value. But concavity, there's not a concavity here, So we're going to, from 5 to 7, we're going to have to pass through with a straight line. And now we get back to here, F starts decreasing again, so what does that say about the concavity of G? It's concave down. So we're increasing in concave down here. So we're here. So if you look at it, we said earlier the extrema were here, here, and here, and that worked out, that checked out. But we've also got the concavity knocked out.